Section 9. CBR test. Now the CBR test diagram is given. This is a laboratory test that measures subgrade strength. The lower the CBR value, the weaker the soil, and the more pavement thickness will be required. Section 10. CTB and CTSB layers. The CTB and CTSB layers are now shown. CTB means cement-treated base. CTSB means cement-treated sub-base. These are stabilized layers which increase strength and helps in reducing pavement thickness. Section 11. Pavement response. Now the pavement response diagram is given. When load is applied, the pavement deflects. Stress and strain develop inside it. This behavior is the basis of pavement design. Section 12. Bottom summary. Now the summary is given below. In Part-2 we cover material, CBR, drainage, and response. And the most important line is, better material means better pavement performance. Key takeaway. Good material means good strength. Good drainage means long life. Good construction means better performance. Closing. So friends, in Part 2 we will discuss pavement behavior. We will understand the foundation of this. After this, in the next parts we will learn the actual pavement design calculations and IRC, SANTES procedures in detail. Stay connected with Civil Engineering Infrastructure. Thank you. IRC SANTES Flexible Pavement Design Part 2 Overview. Welcome to Civil Engineering Infrastructure. This is Part 2 of the IRC SANTES Flexible Pavement Design Series. Part 1 we understood the basics, layers and load concept. Now in Part 2 we will move ahead and understand material behavior, CBR, drainage and pavement response. This Part 2 we will cover the complete overview from slide 11 to slide 20. Section 8. Part Introduction. Slide reads. This is Part 2 of IRC SANTES Flexible Pavement Design Series. And this section covers material behavior, stabilized layers, and pavement response concepts. It is clearly written in the engineering note that material behavior and layer interactions control pavement performance. That means the strength of the pavement does not come only from its thickness. Material quality and interaction of layers are equally important. Section 2. Content structure. Now a table is given in the middle in which the complete structure from slide 11 to slide 20 is given. Subgrade compaction and density in slide 11. It controls strength and stability. California bearing ratio CBR in slide 12. This subgrade is used for strength evaluation. Effective CBR concept in slide 13. That means combined subgrade behavior. Drainage in pavement in slide 14. This is important for water control and durability. Cement treated base CTB in slide 15. This is a stabilized base layer. Cement-treated sub-base CTSB in slide 16. This improves foundation support. Bituminous material basics in slide 17. That is binder properties and behavior. Aggregate properties in slide 18. This defines strength and durability. Temperature and moisture effects in slide 19. This directly affects pavement performance. Pavement response to load in slide 20. That means stress and strain behavior. In this part we will discuss the behavior of pavement. We'll understand not just layers. Section 10. Learning outcome. Now let us see the learning outcome. After this part you will understand soil strength concepts, knowledge of stabilized layers, importance of drainage, material behavior, and pavement response fundamentals. That means now your understanding will be strong at the practical level. Section 4. Pavement layer sketch. Now the same flexible pavement layered structure has been given on the right side. There is a wheel load on top. And below are the layers. Bituminous concrete IEBC. Dense bituminous macadam IEDBM. Wet mix macadam IEWMM. Granular sub-base IEGSB. And compacted subgrade. It transfers the entire system load from top to bottom. Section 5. Load distribution mechanism. The load distribution diagram is given below. Wheel load comes from above. And going down through the layers it gets spread. This load distribution mechanism is the core concept of pavement design. Section 6. Many layer diagrams. Now many layer diagrams are given on the right side. The GSB layer provides drainage and support. The WMM layer distributes the load and provides stability. BC layer gives smooth surface and waterproofing. The DBM layer acts like a binder course. That means every layer has a specific function. Section 7. Flow understanding. Now let us understand the flow. First of all, let us understand material properties. Then soil strength. Then stabilization. Then drainage control. And finally pavement response. That is, this entire sequence of pavement behavior it is necessary to understand the. Section 8. Practical engineering note. Now practical note is very important. When CBR is low, pavement thickness increases. Due to poor drainage, the entire pavement system becomes weak. Structural strength decreases due to improper compaction. These three things are the major causes of site fail. SLID 11. Bituminous layers in flexible pavement. So friends, till now we have understood granular layers IEGSB and WMM. But now let us understand the most visible, most critical, and directly traffic-carrying portion of the pavement. And that is bituminous layers. These layers remain in direct contact with the vehicle tire. This decides the riding quality. And this controls the pavement durability. If the bituminous layer is properly designed and compacted, so the road becomes smooth, safe, and long-lasting. But if the temperature, mix quality, or compaction is poor, so the pavement may fail quickly. So let us now understand the entire slide in detail. एक introduction to bituminous layers are asphalt-based pavement layers, which are provided above the granular layers. Their main work: direct wheel load carrying, providing smooth riding surface. And here bitumen works to bind the aggregates. See the engineering note below. Bituminous layer performance controls pavement riding quality and durability. And this is a very important concept in practical highway engineering. Now let us look at the second topic. To keycap main bituminous layers in flexible pavement. Main bituminous layers are shown here. A. Wearing course. B. Binder course. Now both have different functions. Wearing course remains in direct traffic contact, whereas binder course provides structural support. Now let us look at the third topic. Teen wearing course is the topmost pavement layer, which is directly in contact with traffic and environment. Let us understand its functions. Smooth riding surface, skid resistance, waterproofing, traffic wear resistance, noise reduction. अब कॉमन मटेरियल्स देखिए. बिचुमिनस कंक्रीट यानी BC, स्टोन मैट्रिक्स एस्फाल्ट SMA. Now look at the typical thickness. Generally 30 mm to 50 mm. Now see the important points below. Surface quality mainly depends on wearing course. That means riding comfort depends on this layer. Now let us look at the fourth topic. Char binder course is the intermediate asphalt structural layer, which is provided below the wearing course. Let us understand its functions. Load distribution, structural support, improves pavement strength, connects surface and base layer. Now look at the common material. DBM means dense bituminous macadam. Now look at the typical thickness. Generally 50 mm to 120 mm. See the engineering note below. Binder layer carries major bituminous structure load, and this pavement plays an important role in structural behavior. Now let us see the right side paving operation image. This shows the actual hot mix asphalt paving operation. Visible here are the bitumen tanker, sensor paver, and tandem roller. Construction flow is also given below. Step 8. Bitumen tanker. Step 2. Hot mix transportation. Step 3. Sensor paver. Step 4. Initial rolling. Step 5. Intermediate rolling. Step 6. Finish rolling. And this is the standard paving sequence followed in highway projects. Now let us look at the fifth topic. 6 types of bitumen used. VG10, cold climate works. VG30, normal highway works. VG40, heavy traffic and hot climate. Now modified bitumen is also used, which is useful on high-performance roads. Now let us look at the seventh topic. 7 construction procedure. Now let us understand the bituminous layer construction sequence. Step 8. Surface cleaning. Step 2. Prime coat or tack coat application. Step 3. Hot mix transportation. Step 4. Mechanical paving by sensor paver. Step 5. Initial rolling. Step 6. Intermediate rolling. Step 7. Finish rolling. Step 8. Joint finishing and temperature control. Now look at the thermometer on the side. Temperature control is very critical for proper compaction. If the temperature drops, so both density and compaction get affected. Now let us look at the eighth topic. Art quality control requirements. Quality control is very important in bituminous work. Which tests are required? Bitumen content test, Marshall stability test, temperature checking, density testing, thickness measurement, surface level checking, and these tests ensure pavement quality. Now let us look at the ninth topic. No important engineering concepts. Temperature control is critical during paving. Improper compaction causes rutting. Low binder content causes raveling. Excess binder causes bleeding. And these practical field problems appear frequently on the site. Now let us look at the 10th topic. COMMON failures in bituminous layers. Fatigue cracking, rutting, raveling, potholes, stripping, and if the drainage and compaction are not proper. So these failures develop quickly. Now let us look at the 11th topic. 1 practical site observation. Temperature loss during transport reduces compaction quality. Segregation causes weak patches. Poor joint construction creates longitudinal cracks. Water infiltration weakens asphalt layers rapidly. And the site engineer should pay special attention to these observations. Now let us look at the 12th topic. 1 to interview question box. Q. Which layer directly contacts vehicle tire? Answer. Wearing course. Q. Why is tack coat applied? Answer. To provide bonding between layers. Now let's look at one short revision below. BC. Riding quality plus skid resistance. DBM. Load distribution plus structural strength. WMMGSB. Support structure plus drainage. Subgrade. Foundation soil plus load support. See the load distribution diagram below. Wheel load is spreading from top to bottom. And stress is decreasing with depth. Now look at the final concepts at the bottom. Higher temperature control. Better compaction plus better performance. But poor drainage. Asphalt damage plus pavement failure. Find this practical highway engineering explanation useful. Like the video, subscribe to the channel, and press the bell icon, so that you do not miss such detailed technical videos of pavement engineering. And now in the next slide, we will understand pavement drainage system and water effect, where we will understand in detail the drainage failure, water damage, moisture effect, and pavement deterioration mechanism. SLID 12. Drainage requirements in flexible pavement. So friends, till now we have understood pavement layers. GSB, WMM and bituminous layers. But now we will understand that factor causes most pavement failures. And that is water. If water enters the pavement, so even the strongest pavement can fail quickly. That is why a famous line is said in highway engineering. Water is the enemy of pavement. And this entire concept is explained in detail in this slide. So let us understand the entire slide step by step. 1. Introduction to pavement drainage. Drainage is a system which removes surface and subsurface water from the pavement structure. Now what is the most important thing here? Water is the major cause of pavement deterioration. If water penetrates the pavement layers, so the subgrade starts becoming weak. CBR is reduced, and pavement distress begins. But what does proper drainage do? Pavement strength increases service life. See the engineering note below. Good drainage is essential for durable pavement performance. And this is a very critical concept in the field of engineering. Now let us look at the second topic. The objectives of pavement drainage. The main objective of the drainage system: prevent water infiltration, maintain subgrade strength, reduce pavement deformation, prevent stripping and potholes, improve pavement durability. And this is the main purpose of a proper pavement drainage system. Now let us look at the third topic. 3 types of drainage. There are 2 major drainage systems here. A. Surface drainage. It removes rainwater from the pavement surface. Now let's look at the methods. Camber, cross slope, side drain, median drain. Now see the important points below. Surface water should be removed rapidly, because standing water increases pavement damage. Now let's look at the second type. B. Subsurface drainage. It removes the water present inside the pavement layers. Now let's look at its methods. Drainage layer, perforated pipe drain, filter media, edge drain. See the engineering note below. Subsurface water weakens pavement foundation rapidly. And this is the reason why the pavement foundation starts becoming weak. Now let us look at the fourth topic. 4 keycap effect of water on pavement. Now let us understand how water damages pavement. Reduces subgrade CBR. Causes stripping of bitumen. Produces potholes. Increases rutting. Causes pumping action. Reduces pavement life. And so here in the yellow box it says, water is the enemy of pavement. Now let us look at the right side highway drainage section. This complete drainage mechanism is shown. The camber is given above, due to which rainwater flows towards the side. Shoulder slope is also given, so that water can drain into the shoulder area. Then below is the side drain, filter media, and perforated pipe drain shown, which removes subsurface water. And this is the complete highway drainage system. Now let us look at the fifth topic. Part camber and cross slope. What is camber? Upward convex shape given on the road surface, whose purpose is to provide drainage. Now look at the IRC values. Bituminous surface 2% to 3%. Concrete surface 1.7% to 2%. Shoulder 3% to 4%. The camber diagram below also shows the same. Now let us look at the sixth topic. 6 drainage layer functions. Drainage layer. Collect seepage water. Prevent water accumulation. Protect subgrade. Improve pavement stability. See the drainage layer detail below. Base course, GSB drainage layer, filter media, and subgrade are shown. And the seepage water is reaching the perforated drain below. Now let us look at the seventh topic. 7 important engineering concepts. Water decreases pavement strength rapidly. Poor drainage accelerates pavement failure. Proper shoulder drainage is equally important. Edge drainage improves pavement performance. Look at the infiltration diagram below. Water is entering the pavement from above, and by reaching subgrade it is reducing the strength. This is the actual field problem. Now let us look at the eighth topic. 8 common drainage failures. Water stagnation, shoulder erosion, edge failure, potholes, stripping, settlement, and these failures are shown in the right side images. Now let us look at the ninth topic. No practical site observation. Blocked side drains cause pavement damage. Water stagnation weakens shoulder area. Poor camber causes surface ponding. Inadequate drainage leads to premature pavement failure. And these observations are most visible during field inspection. Now let us look at the 10th topic. Maintenance requirements. Proper drainage maintenance is very important. Cleaning side drains. Removing blockage. Shoulder maintenance. Repairing erosion. Maintaining cross slope. If there is no maintenance, then the drainage system will fail. Now let us look at the 11th topic. 1 interview question box. Why is drainage important in pavement design? Answer. Because water reduces pavement strength and durability. Q. Which drainage type removes surface rainwater? Answer. Surface drainage. Look at the cross-section diagram below. Surface drainage is removing water from above, and subsurface drainage is removing internal water below. Now let's look at the bottom section. Surface drainage features. Camber, cross slope, side drain, median drain. Now look at the subsurface drainage system. Filter media, perforated pipe drain, and edge drain shown. Now look at aggregate and bitumen bonding concept. Strong bond pavement increases durability. Now temperature effect is also given. Viscosity is low at high temperatures. Water can also freeze in low temperatures. And both conditions affect drainage performance. Now see the final conclusion at the bottom. Good drainage, strong pavement. Remove water. Protect foundation. Improve strength. Increase pavement life. And this is the complete drainage engineering concept. And now in the next slide, we will understand failure criteria in flexible pavement, where fatigue failure, rutting failure, and design life criteria will be understood in detail. SLID 13. Fatigue cracking criteria. So friends, till now we have understood pavement composition, drainage system, and load transfer mechanism. But now we will understand that failure mechanism, which is considered the most critical structural concept of flexible pavement design. And that is fatigue cracking. This is the same failure which initially develops inside the pavement, but gradually it damages the entire road surface. And that is why IRC 37 gives a lot of importance to fatigue criteria. So let us now understand the entire slide step by step in detail. Introduction to fatigue cracking. First of all, let us understand what fatigue cracking actually is. Fatigue cracking is the cracking that occurs in the bituminous layer, which develops due to repeated traffic loading and tensile strain. Now what is the most important thing here? This cracking does not start from the top surface. Rather, it starts from the bottom of the bituminous layer and propagates upwards. And that's why sometimes the pavement looks fine from above, but the damage has already started inside. See the engineering note below. Repeated wheel load causes gradual structural damage. And this is the whole base concept of fatigue failure. Now let us look at the second topic, the mechanism of fatigue cracking. Now let us understand how fatigue cracking develops step by step. Step 8. Wheel load comes on the pavement, and tensile stress develops at the bottom of the bituminous layer. Step 2. Due to repeated load repetitions, micro cracks start developing. Step 3. Cracks propagate upwards with traffic movement. Step 4. These cracks become interconnected and form an alligator cracking pattern. And this is called fatigue failure mechanism. Now see the important points below. Fatigue failure depends on load repetition and tensile strain. That means the more traffic repetition there will be, the sooner fatigue damage will develop. Now let us look at the third topic. 10 causes of fatigue cracking. Now let us understand the reasons due to which fatigue cracking develops. Repeated heavy axle loading. Thin bituminous layer. Weak base support. Poor compaction. Aging of bitumen. Temperature variation. And these major causes are most visible in practical highway projects. Now let us look at the fourth topic. 4 types of fatigue cracks. Here are the different fatigue crack patterns. A. Longitudinal cracks. These develop parallel to the traffic direction. B. Alligator cracks. This creates an interconnected block pattern, which looks like crocodile skin. And this is the most common pattern of fatigue failure. C. Wheel path cracks. These develop in heavily trafficked wheel zones, where axle loading is highest. Now let us look at the right side fatigue failure mechanism diagram. The wheel load is acting above. The load is being distributed in the following layers. But maximum tensile strain is developing at the bottom of the bituminous layer. And this is the crack initiation zone. Now look at the realistic fatigue pattern on the right side. This is showing the actual alligator cracking appearance. Now let us look at the fifth topic. C. 5 fatigue failure zone. Clearly explained here where maximum tensile strain develops. Bottom of bituminous layer. And this location is the main zone of fatigue cracking initiation. Now see the engineering concept below. Higher tensile strain reduces pavement fatigue life. That means the higher the tensile strain, the pavement life will be that much less. Now let us look at the sixth topic. 6 important IRC 37 concept. IRC 37 fatigue criteria mainly control what things? Bituminous layer thickness. Structural pavement life. That means this is the main objective of pavement design, so that cracking remains under control despite repeated loading. Now let us look at the seventh topic. 7 important formula box. Now here is the fatigue life equation. N_F_1 left frac 1, where epsilon_T right F_2 left frac 1 E right F_3, where N_F represents fatigue life, epsilon T is the bottom tensile strain, and E is the elastic modulus. If you understand in simple language, higher tensile strain means lower fatigue life, and better stiffness means higher fatigue resistance. Now let us look at the eighth topic. 8 factors affecting fatigue life. On which factors does fatigue life depend? Bitumen quality, pavement thickness, traffic loading, temperature, compaction quality, base layer stiffness. If the compaction is not proper, then fatigue failure will develop quickly. Now let us look at the ninth topic. No engineering concepts. Thick bituminous layer reduces tensile strain. Better compaction increases fatigue resistance. Overloaded trucks accelerate cracking. Temperature affects asphalt flexibility. And this is what is visible in the actual pavement behavior field. Now let us look at the 10th topic. COMMON signs of fatigue failure. Interconnected cracking. Surface breakdown. Loose aggregates. Water infiltration. Pothole formation. And if these signs are not repaired on time, so the pavement starts deteriorating rapidly. If you are still finding the explanation useful, please like the video, subscribe to the channel, and support civil engineering infrastructure. Because here you will get practical concepts of highway engineering, site observations, and IRC-based real engineering explanation will be available in detail. Now let us look at the 11th topic. 1. Practical site observation. Wheel path areas crack first. Poor joint construction accelerates fatigue failure. Thin overlay fails quickly in heavy traffic. Water penetration increases crack propagation. And these observations are commonly seen during site inspection. Now let us look at the 12th topic. 1. Prevention methods. How can fatigue cracking be controlled? Proper pavement thickness. High quality compaction. Better drainage. Timely crack sealing. Controlled axle loading. And this is the base concept of long-lasting pavement design. Now let's see the one-shot revision below. Repeated traffic loading produces tensile strain. High tensile strain reduces fatigue life. Thicker asphalt layer provides better fatigue resistance. Good drainage and good compaction increase fatigue life. And fatigue control means long-lasting pavement. Now let's look at the interview question box. Q. Where does fatigue cracking initiate? Answer. At the bottom of bituminous layer. Q. What is alligator cracking? Answer. Interconnected fatigue cracks caused by repeated traffic loading. And this entire fatigue cracking criteria, IRC, SATIS, is the most important structural failure concept in pavement design. And in the next slide, we will understand rutting failure criteria, where permanent deformation, wheel path rutting, and subgrade deformation will be understood in detail. Slide 14. Rutting criteria in flexible pavement. We now understand a very important failure criterion for flexible pavement. Rutting criteria in flexible pavement. Permanent deformation under traffic loading. Understand this whole concept step by step. 1. Introduction to rutting. Rutting is the permanent longitudinal deformation that develops in the wheel path due to repeated wheel loading. This forms a depression, and vehicles start settling down in the same path. Engineering note. Develops in heavy traffic lanes. Though mechanism of rutting failure. Step 1. Heavy wheel load vertical compressive stress applied does. Step 2. Repeated loading densifies the layers. Step 3. Wheel path depression develops. Step 4. Permanent rut formation takes place. Important point. Rutting is a cumulative permanent deformation. 3 major causes of rutting. Weak subgrade. Poor compaction. Excess moisture. Overloaded vehicles. Weak granular layers. High pavement temperature. The temperature increases, bitumen becomes soft and deformation increases rapidly. 4 rutting zones in pavement. Rutting different can be in layers. Bituminous layer rutting. Unstable asphalt mix के कारण. Granular layer rutting. Poor density or weak structure. Subgrade rutting. Low CBR or high compressive strain. 5 Effect of rutting. poor riding quality, water stagnation, vehicle instability, accident risk, reduced pavement life. Engineering note: severe rutting creates unsafe driving conditions. 6 important IRC 37 concept. Rutting is controlled by the vertical compressive strain that develops on the subgrade. 7 important formula. जहां NR rutting life, Z compressive strain on subgrade. Compressive strain कम होगी तो rutting life ज्यादा होगी. 8 factors affecting rutting resistance. Proper compaction, higher pavement thickness, better aggregate interlock, strong subgrade, temperature control, good drainage. 9 engineering concepts. Higher compressive strain मतलब lower rutting life. Weak subgrade deformation बढ़ाता है. Water layer stability reduce करता है. Thicker pavement stress reduce करता है. Common signs of rutting: wheel path depressions, water ponding, surface unevenness, edge deformation, asphalt shoving. 1 practical site observation. Rutting is more common in slow lanes. Create deeper ruts. High temperature increases asphalt deformation. Poor shoulder support makes edge rutting worse. 1-2 route depth and progression. 0 mm means no rutting. 10 to 15 mm minor rutting. Severe rutting greater than 25 mm. Slowly failing develops. New initial moderate severe rutting. 1-3 tensile versus compressive concept. Tensile strain on bituminous layer bottom. Fatigue cracking. Compressive strain on subgrade. Rutting. यही IRC 37 डिजाइन का बेस कॉन्सेप्ट है. 1-4 prevention methods. Proper thickness design. Good compaction. Drainage improvement. Stable asphalt mix. Overloading control. 1-5 interview questions. Q. What controls rutting? Ans. Vertical compressive strain on subgrade. Why does rutting occur in the wheel path? Answer. Repeated load is concentrated in the same zone. FINAL one-shot revision. Repeated loading. Permanent deformation. Weak subgrade. Higher rutting. Good compaction. Better performance. Poor drainage. Rapid damage. Final message. Control rutting today. Ensure smooth roads tomorrow. SLID 15. Pavement design life and reliability. So friends, till now we have understood fatigue cracking, rutting failure, and pavement distress mechanisms. But now comes the most important question. For how many years will a pavement perform safely? And how does an engineer consider future uncertainty while designing? And this concept has been explained in detail in this entire slide. Pavement design life and reliability. So let us now understand the entire slide step by step. 1. Keycap introduction to pavement design life. First of all, let us understand what design life is. Design life is that period during which the pavement performs satisfactorily without major structural failure. That means the pavement should be like this, which can safely carry expected traffic throughout its service life. IRC 37 designs pavement considering cumulative traffic loading. Because traffic increases every year, and the stress on the pavement also keeps increasing continuously. See the engineering note below. Pavement should safely carry expected traffic throughout its design life. And this is the main objective of pavement engineering. Now let us look at the second topic. दो typical IRC 37 design life. Now the typical design life of different pavement categories is given in IRC 37. Flexible pavement 15 years. Expressways and high traffic corridors 20 years or more. And the overlay design depends on the residual pavement condition. Now see the important points below. Higher traffic roads require higher structural reliability. That means the more the traffic, the reliability requirement will also be higher. Now let us look at the third topic. 10 objectives of design life. What is the objective of pavement design life? Long-term pavement performance, economical maintenance, structural safety, riding comfort, reduced rehabilitation frequency. और यही प्रॉपर पेवमेंट डिजाइन फिलॉसफी का बेस है. Now let us look at the fourth topic. 4. What is reliability? Now let us understand the concept of reliability. Reliability is the probability that the pavement will perform satisfactorily under expected traffic and environmental conditions during its design life. If you understand in simple language, reliability means providing a safe design by considering future uncertainty. See the engineering note below. Reliability accounts for uncertainties in design and field conditions. Because actual field conditions are not always ideal. Traffic variation, drainage issue, overloading, poor compaction. All these affect pavement performance. Now let us look at the fifth topic. 5 factors affecting reliability. On which factors does reliability depend? Traffic variation, construction quality, material properties, drainage condition, climatic variation, axle overloading. And in practical highway projects, these factors directly affect pavement life. अब राइट साइड पेवमेंट लाइफ साइकिल डायग्राम देखते हैं. स्टेज 1 इनिशियल एक्सलेंट कंडीशन. स्टेज 2 ग्रेजुअल डेटेरियोरेशन अंडर ट्रैफिक. स्टेज 3 विजिबल डिस्ट्रेस फॉर्मेशन. स्टेज 4 मेंटेनेंस रिक्वायरमेंट. स्टेज 5 रिहैबिलिटेशन और ओवरले. This is the entire pavement life cycle. And this is the reason why timely maintenance is very important. Now let us look at the sixth topic. 6 keycap importance of reliability in pavement design. Why is reliability important? Reduces risk of premature failure. Improves pavement durability. Ensures safer design. Increases confidence in structural performance. And this is why higher reliability is adopted in important highways. Now let us see the pavement serviceability decline curve below. This graph shows how pavement condition decreases with time. Initially the pavement is in excellent condition. Then crack initiation begins. Then crack propagation and rutting development occurs. After that maintenance becomes required. And finally rehabilitation or overlay is required. This is the actual pavement deterioration behavior. Now look at the right side serviceability level guide. Psi 4 to 5. Very good. Psi 3 to 4. Good. Psi 2 to 3. Fair. Psi 1 to 2. Poor. Psi 0 to 1. Very poor. and pavement rehabilitation is generally required in lower psi condition. Now let us look at the seventh topic. Saat pavement performance concept. Pavement performance deteriorates in different stages. Stage 1. Initial excellent condition. Stage 2. Gradual deterioration under traffic. Stage 3. Visible distress formation. Stage 4. Maintenance requirement. Stage 5. Rehabilitation or overlay. And this is called full pavement service cycle. Now let us look at the eighth topic. Art pavement serviceability loss. Now let us understand why pavement serviceability reduces. The main causes are fatigue cracking, rutting, water damage, aging of bitumen, traffic overloading. And these failures are shown in the side images. Now let us look at the ninth topic. No important engineering concepts. Higher reliability requires stronger pavement. Overloaded traffic reduces design life rapidly. Good drainage increases pavement life. Timely maintenance delays deterioration. And these are practical pavement engineering concepts. Find this detailed IRC SATIS explanation useful. Please like the video, subscribe to the channel, and support civil engineering infrastructure. Because here you will get practical concepts of highway engineering, IRC-based design explanation, and real site observations are available in detail. Now let us look at the 10th topic. DSIGN considerations in IRC SATIS. Factors does IRC SATIS consider while designing? Traffic growth projection, cumulative axle loading, climatic effects, material stiffness, fatigue and rutting criteria. On the basis of all these parameters, the pavement thickness is finalized. Now let us look at the 11th topic. 1. Practical site observation. Pavement deterioration occurs rapidly in mining roads. Poor maintenance reduces service life. Water stagnation accelerates structural failure. Reduces pavement life drastically. And these actual field observations are commonly seen in highway projects. Now let us look at the 12th topic. 2 common reasons for premature failure. Incorrect traffic prediction, poor compaction, weak drainage, thin pavement layers, low quality materials. And if these mistakes happen in the design or construction stage, so the pavement may fail quickly. Now let us look at the maintenance and rehabilitation sequence. Crack sealing, patching, microsurfacing, mill and overlay, full depth rehabilitation. And this is the standard pavement maintenance sequence. Look at the traffic growth graph below. Traffic volume is increasing every year. And this is the reason why future traffic projection is very important. Now let's look at the interview question box. Q. What is design life in pavement engineering? Answer. Period during which pavement performs satisfactorily without major structural distress. Q. Why is reliability important in pavement design? Answer. Because actual field conditions vary from assumed design conditions. Now let's see the one-shot revision below. Design life represents the expected service period. Results in safer pavement designs. Good maintenance increases pavement life. Poor drainage causes rapid structural damage. where pavement deterioration is shown from no rutting to severe rutting. And this entire concept is the foundation of pavement design life and reliability engineering. And in the next slide, we will understand flexible pavement thickness design, where IRC, SANTE's design charts, layer thickness selection, and pavement composition will be understood in detail. SLID Solar Climatic considerations in flexible pavement. So friends, till now we have understood the concepts of pavement design life, reliability, and pavement deterioration. Comes a very important factor, which continuously affects pavement performance. And that is climate. Because no matter how good the pavement design is, if climatic conditions are not properly considered, so the pavement starts deteriorating quickly. That is why climatic considerations are given great importance in IRC SANTEs. So let us now understand the entire slide step by step in detail. एक introduction to climatic effects. First of all, let us understand how climate affects pavement. Climate significantly influences the performance and durability of flexible pavement. Temperature and moisture variation affect pavement strength, deformation, and cracking behavior. Bitumen starts becoming soft at high temperature, and excessive moisture weakens the subgrade. See the engineering note below. Environmental conditions directly control pavement deterioration rate. And this is a very important concept of practical highway engineering. Now let us look at the second topic. Domain climatic factors. Here are the major climatic factors. A. Temperature. B. Rainfall and moisture. C. Freeze and thaw effect. D. Solar radiation. And all these factors directly influence pavement performance. Now let us look at the third topic. 3 keycap effect of temperature on pavement. Now let us understand how temperature affects the pavement. High temperature effects. Softening of bitumen. Increased rutting. Asphalt deformation. Bleeding tendency. That means in high temperature the bituminous layer becomes soft and starts deforming. Now let us see the low temperature effects. Bitumen hardening. Shrinkage cracking. Reduced flexibility. And for this reason thermal cracking is more visible in cold regions. Now see the important points below. Asphalt behavior changes significantly with temperature. And this is the reason why climate-based bitumen selection is very important. Now let us look at the fourth topic. 4 keycap effect of moisture on pavement. Now let us understand how moisture damages the pavement structure. Reduction in subgrade CBR. Weakening of granular layers. Stripping of bitumen. Pothole formation. Loss of pavement stability. And in practical field conditions, water infiltration is considered the most dangerous problem. See the engineering note below. Water is one of the most destructive elements for flexible pavement. And this is why drainage system is so important. Now let us look at the climate effect diagram on the right side. In summer conditions, heat is softening the bitumen, due to which routing is increasing. Water infiltration during rainy season is weakening the pavement layers and subgrade. And in winter season low temperature shrinkage is creating cracking. This is the actual climatic pavement behavior. Now let us look at the fifth topic. 5 keycap climatic influence on pavement layers. Now let us understand the climate effect on different pavement layers. Bituminous layer. It is affected by temperature susceptibility. Granular layer. It is affected by moisture and drainage conditions. Subgrade. Water content is affected by variation. And this is the reason why it is necessary to make the complete pavement system climate resistant. Now let us look at the sixth topic. Share drainage and climate relation. Proper drainage controls moisture loss. Improves pavement life. Prevents shoulder drainage erosion. And water stagnation accelerates pavement failure. See the drainage section diagram below. Camber is making the water flow towards the sides. And the shoulder drain is safely removing the water. This is the ideal highway drainage condition. Now let us look at the seventh topic. Temperature susceptibility of bitumen. Now let us see the climatic suitability of different bitumen grades. VG10. Cold climate. VG30. Moderate climate. VG40. Hot climate and heavy traffic. Modified bitumen. Extreme climatic conditions. And on this basis bitumen grade selection is done. Now let us look at the eighth topic. Art engineering concepts. Higher temperatures increase rutting risk. Moisture reduces subgrade strength. Climatic effects should be considered during material selection. And this is the practical solution to long-term pavement performance. Now let's look at the interview question box. Q. Why is climate important in pavement design? Answer. Because temperature and moisture affect pavement strength and durability. Q. Which climatic factor reduces subgrade strength? Answer. Moisture and water infiltration. Now let us see the pavement aging and service life concept below. Pavement life is longer in good drainage conditions. But in poor drainage conditions, serviceability starts reducing quickly. Now look at the right side serviceability decline curve. With the increase in time and traffic loading, the pavement condition is decreasing. And finally the maintenance threshold and rehabilitation stage arrives. Now let's see the one-shot revision below. High temperature means rutting risk. Low temperature means cracking risk. Excess moisture means weak pavement. And good drainage means better pavement life. This entire climatic consideration concept is called the environmental foundation of flexible pavement design. And in the next slide, we will understand axle load and vehicle damage factor, where we will understand axle configuration and pavement damage mechanism in detail. And this is the practical solution to long-term pavement performance. Now let's look at the interview question box. Q. Why is climate important in pavement design? Answer. Because temperature and moisture affect pavement strength and durability. Q. Which climatic factor reduces subgrade strength? Answer. Moisture and water infiltration. Now let us see the pavement aging and service life concept below. Pavement life is longer in good drainage conditions. But in poor drainage conditions, serviceability starts reducing quickly. Now look at the right side serviceability decline curve. With the increase in time and traffic loading, the pavement condition is decreasing. And finally the maintenance threshold and rehabilitation stage arrives. Now let's see the one-shot revision below. High temperature means rutting risk. Low temperature means cracking risk. Excess moisture means weak pavement. And good drainage means better pavement life. This entire climatic consideration concept is called the environmental foundation of flexible pavement design. And in the next slide, we will understand axle load and vehicle damage factor, where we will understand axle configuration and pavement damage mechanism in detail. SLID 17. Axle load survey and traffic loading. So friends, till now we have understood the concepts of climate effect, drainage, and pavement performance in detail. But now we will understand that parameter which directly controls pavement damage. And that is axle load. Because pavement failure doesn't happen just because of traffic volume. Rather, it depends on the axle load intensity of the vehicle. That is why axle load survey has been considered very important in IRC Santis. So let us now understand the entire slide step by step in detail. 1. Keycap Introduction to Axle Load Survey. First of all, let us understand what axle load survey is. Axle load survey is the process of measuring axle loads of commercial vehicles. This is done to determine the actual traffic loading running on the highway. That means how much real load is coming on the pavement. It is measured. See the engineering note below. Actual axle load governs pavement damage and design thickness. And this is the fundamental concept of IRC pavement design philosophy. Now let us look at the second topic. 2 Keycap Objectives of Axle Load Survey. Axle load survey done. Determine traffic loading characteristics. Calculate vehicle damage factor i.e. VDA. Assess overloading condition. Estimate pavement design traffic. Improve pavement reliability. And this data is further used in pavement thickness design. Now let us look at the third topic. 10 types of axle configurations. Now let us understand axle configurations. A. Single axle. An axle carries the wheel load. B. Tandem axle. There are 2 closely spaced axles. C. Tridem axle. There is a 3-axle group arrangement. Now see the important points below. Axle configuration affects pavement damage intensity. This means that even under the same load, the axle arrangement changes the damage behavior. Now let us look at the fourth topic. CHAR Standard Axle Concept. Uses the standard axle load concept. Here standard axle load, a CKN, has been given. This means that all actual axle loads are converted into equivalent standard axle repetitions. See the engineering note below. Heavier axle loads create exponentially larger pavement damage. This means that if the axle load increases slightly, the damage increases significantly. Now look at the right side weighbridge image. This is static weighbridge station, where truck axle loads are being measured. And this is the actual traffic loading data collection process. Now let us look at the fifth topic. 5 Axle load survey methods. Now let us understand different survey methods. A. Static weighbridge. Axle load measurement is done by stopping the vehicle. B. Weigh in motion i.e. WIM. Axle load measurement is done while the vehicle is moving. C. Portable axle load system. Temporary survey arrangement is used. And the WIM system is increasingly being used in practical highway projects. Now let us look at the sixth topic. 6 Traffic loading behavior. Cause maximum pavement damage. Reduce pavement life. Repeated axle loading produces fatigue and rutting. And traffic growth increases cumulative loading. This is the reason why it is considered a governing parameter in commercial traffic pavement design. Now let us look at the seventh topic. 7th important engineering concept. Now understand the most important concept of the yellow box. Small increase in axle load. Large increase in pavement damage. This means that if the axle load increases slightly, the pavement damage increases manifold. And this is the main reason for the dangerous effect of overloaded trucks. Now let us look at the 8th topic. Art vehicle damage factor relation. Now let us understand VDF relation. VDF depends on axle load magnitude, axle configuration, traffic composition, overloading frequency. Here is the formula. VDF L bata 80 N, where L actual axle load, 80 standard axle load, N empirical exponent, and for flexible pavement the value of N is generally considered to be around 4. This is called the fourth power damage law. Now let us look at the 9th topic. No common traffic loading effects. Rutting, fatigue cracking, surface deformation, settlement, edge failure. And these pavement distresses are shown in the images below. Now look at the WIM system diagram on the right side. Sensors are installed inside the road, and load data is being collected while the vehicle is moving. Traffic loading is then evaluated through data acquisition systems and computer analysis. This is modern axle load survey technology. Now let us look at the 10th topic. PRACTICAL site observation. High axle loading is seen in mining corridors. Commercial traffic intensity is higher on toll roads. Overloaded trucks create severe rutting. Receive maximum axle repetitions. And this is why slow lanes deteriorate quickly. Now let us look at the 11th topic. 1 common errors in axle load survey. Short survey duration. Incorrect vehicle classification. Calibration errors. Ignoring seasonal variation. If the survey is not correct, then the pavement design will also become inaccurate. Now let us look at the 12th topic. 1-2 importance in IRC 37 design. Axle load survey data कहाँ यूज होता है? VDF calculation, pavement thickness design, cumulative MSA estimation, pavement safety and economy improvement. और यही एक्चुअल डिजाइन ट्रैफिक फाउंडेशन होता है. अब इंटरव्यू क्वेश्चन बॉक्स देखते हैं. Q. What is standard axle load in IRC pavement design? Answer. 80 kN standard axle. Q. Why is axle load survey important? Answer. Because actual axle load determines pavement damage. अब नीचे axle load examples देखिए. Single axle 7 to 10 टन. Tandem axle 16 to 20 tons. Tridem axle 24 to 30 tons. Clearly written below. Higher axle load, higher pavement damage. Let's look at the one-shot revision at the bottom. Axle load survey means traffic loading measurement. Heavy axle load means higher pavement damage. Overloading means reduced pavement life. And commercial vehicles govern design traffic. CI family. find this detailed highway engineering explanation useful. So please like the video, subscribe to the channel, and press the bell icon. You keep getting such complete civil engineering concepts continuously. And in the next slide, we will understand vehicle damage factor and SL concept, where equivalent standard axle load, damage conversion, and pavement design relation will be understood in detail. SLID 18. Design charts and pavement thickness design. So friends, till now we have understood the concepts of axle load survey, traffic loading, and pavement damage. But now comes the most important stage. Actual pavement thickness design. That means how much thickness should be given. How many layers will there be? And how is pavement designed using IRC 37 chart? This entire concept is given in detail in this slide. So let us understand the entire slide step by step. 1. Keycap Introduction to Pavement Design Charts. IRC 37 provides design charts to determine pavement thickness. And these charts mainly depend on design traffic, subgrade CBR, pavement performance criteria. That is, pavement thickness is decided on the basis of traffic and soil strength. See the engineering note below. Pavement thickness increases with traffic loading and decreases with higher CBR. That means if there is more traffic, then the pavement will become thick. And if the CBR is higher, then the thickness will appear less. This is the core principle of flexible pavement design. Now let us look at the second topic. The purpose of design charts. The purpose of design charts. Determine pavement layer thickness. Simplify pavement design procedure. Ensure structural adequacy. Maintain pavement performance. Improve design efficiency. And engineers use these IRC charts in practical highway projects. Now let us look at the third topic. 3 keycap parameters used in design charts. Now let us understand on which parameters the design chart depends. 8. Design traffic. This is measured in MSA. Higher MSA. Higher pavement thickness, because there will be more traffic loading. B. Subgrade CBR. Lower CBR. Higher pavement thickness, because weak soil needs stronger pavement support. C. Pavement layer material. Bituminous layer, granular base, sub-base layer. The quality of these materials also affects pavement thickness behavior. Now let us look at the fourth topic. 4 pavement thickness components. Now let us understand pavement thickness components. A. Bituminous layer thickness. It provides fatigue resistance and riding quality. B. Base layer thickness. It provides structural strength. C. Sub-base thickness. It provides drainage and support. And the same arrangement is shown on the right side in the typical pavement layer structure. Above. Then WMM base course. Then GSB sub-base. And the compacted subgrade below. This is the actual flexible pavement composition. Now let's look at the IRC design chart in the middle. This chart shows the total pavement thickness for different CBR values and traffic categories. As CBR will be lower, so the thickness will be more, and the traffic category will increase, so the pavement structure will have to be made stronger. Now let us look at the fifth topic. 5 THICK analysis selection procedure. Now let us understand the actual pavement thickness selection process. Step 8. Determine design traffic in MSA. Step 2. Determine effective CBR value. Step 3. Select appropriate IRC design chart. Step 4. Read total pavement thickness. Step 5. Divide thickness into pavement layers. और यही स्टैंडर्ड IRC 37 डिजाइन मेथडोलॉजी है. Now let us look at the sixth topic. 6 typical thickness trend. Now this concept is very important. Low traffic plus high CBR. Thin pavement. High traffic plus low CBR. Thick pavement. See the engineering note below. Weak subgrade requires thicker structural support. And this is the reason why pavement thickness is kept higher in black cotton soil areas. Now let us look at the seventh topic. 7 important engineering concepts. Bituminous thickness controls fatigue life. Granular thickness reduces subgrade stress. Higher stiffness improves load distribution. Drainage layer improves durability. And this is the complete structural pavement behavior. Now let us look at graph concepts. The first graph shows higher CBR, lower thickness. That means if there is a stronger soil foundation, the pavement thickness reduces. The second graph shows higher traffic, higher thickness, because cumulative axial loading increases. Now let us look at the thin versus thick pavement concept. Thin pavement, higher stress on subgrade, more rutting, more cracking, shorter life. Whereas in thick pavement, lower stress, less rutting, less cracking, longer life. And this is the reason why proper thickness selection is very important. Now let us look at the 8th topic. 8 common design mistakes. Incorrect CBR selection. Wrong traffic estimation. Ignoring drainage condition. Inadequate layer thickness. Improper material selection. And these mistakes become the main reason for premature pavement failure in field projects. अब 9वां टॉपिक देखते हैं. 9 practical site observation. Mining roads require thicker pavement structure. Low CBR stretches show rapid deformation. Overloaded traffic demands stronger bituminous layers. Thin pavement sections crack earlier. And it is very important to modify the thickness according to the site condition. Now let us look at the 10th topic. COMMON distresses due to poor thickness design. Fatigue cracking, rutting, settlement, surface deformation, edge failure. And these failures develop due to wrong pavement thickness design. Now let us look at the 11th topic. 1 IRC 37 design philosophy. Pavement design should satisfy fatigue criteria, routing criteria, structural adequacy, serviceability performance. और यही complete IRC pavement design philosophy है. अब इंटरव्यू क्वेश्चन बॉक्स देखते हैं. Q. Which two main parameters govern pavement thickness? Answer. Design traffic and subgrade CBR. Q. Why are design charts used in IRC 37? Answer. To simplify pavement thickness selection process. अब नीचे pavement stress distribution diagram देखिए. High stress above. Then as the depth increases, the stress gradually decreases. And the stress becomes minimum at the subgrade level. This is the layered load distribution mechanism. अब सबसे नीचे वन शॉट रिवीजन देखते हैं. Axle load survey. Measurement of traffic loading. Heavy axle load. 0. Higher pavement damage. Overloading. Reduced pavement life. Correct thickness. Structural adequacy and long life. And the most important thing. Good design plus good construction plus good maintenance. Durable roads. And in the next slide, we will understand advanced pavement materials and stabilized layers, where we will understand CTB, CTSB stabilized base, and advanced pavement strengthening concepts in detail. SLID 19. Cement treated base, CTB, and CTSB. So friends, till now we have understood pavement thickness design, IRC charts, and layer composition in detail. But now we will understand those advanced stabilized layers of flexible pavement, which greatly improves pavement strength. And they are CTB and CTSB. The use of stabilized layers is increasing rapidly in today's modern highways, expressways, and heavy traffic corridors, because these layers increase pavement stiffness, and it also improves pavement life. So let us understand the entire slide step by step in detail. 1. Keycap introduction to stabilized base layers. First of all, let us understand stabilized base layers. Cement-treated layers are such pavement layers which are prepared by mixing aggregates with cement and water. The structural strength and stiffness of these layers is more than normal granular layers. See the engineering note below. CTB improves load distribution and reduces pavement thickness. That means the stabilized layer distributes the load over a wider area, due to which the overall pavement thickness may reduce. Now let us look at the second topic. Though what is CTB? The full form of CTB is Cement Treated Base. Let us understand its definition. CTB is a stabilized base layer in which compaction is done using crushed aggregates, cement, and water. Let us see its functions. Providing structural strength. Improve wheel load distribution. Reducing tensile strain. Improving pavement life. Now look at the typical cement content below. Generally, 3% to 5% cement is used, and this cement stabilization increases the pavement stiffness. Now let us look at the third topic. What is CTSB? The full form of CTSB is Cement Treated Sub-Base. This is a stabilized layer provided below the CTB. Its purpose is to improve support and durability. Let us see its functions. Foundation improvement. Increased stiffness. Reduced deformation. Better moisture resistance. And this is the reason why CTSB proves to be very useful in weak soil stretches. Now let us look at the fourth topic. 4 advantages of CTB and CTSB. Higher structural capacity. Reduced pavement thickness. Better fatigue resistance. Improved rutting resistance. Longer pavement life. अब नीचे important point देखिए. Stabilized layers increase pavement stiffness significantly. And this is the biggest advantage of the stabilized pavement concept. Now let us see the pavement layer arrangement on the right side. The BC layer is given above. Then DBM. Below that is the CTB. Then CTSB. Subgrade at the bottom. Now the wheel load is being distributed downwards. And the load is spreading over a wider area. This is the stabilized pavement load transfer mechanism. Now look at the side box. CTB spreads the wheel load over a wider area. CTSB distributes the load to the subgrade. And subgrade stress gets reduced. Now let us look at the fifth topic. Part construction procedure. Now let us understand the CTB construction process. Step 1. Surface preparation. Step 2. Material proportioning. Step 3. Mixing of aggregates and cement. Step 4. Water addition. Step 5. Mechanical spreading. Step 6. Compaction by vibratory roller. Step 7. Curing process. And this is the proper stabilized layer construction methodology. The construction images below also show the same process. Now let us look at the sixth topic. Importance of curing. Curing is very critical for stabilized layers. Prevents moisture loss. Strength gain increases. Reduces shrinkage cracking. Improves durability. See the engineering note below. Improper curing weakens stabilized layer performance. And ignoring curing in field projects causes cracks to develop. Now let us look at the seventh topic. 7 common problems in CTB. Shrinkage cracking. Improper mixing. Low compaction. Excess moisture. Weak bond with upper layers. And these are the common field problems of stabilized layers. Now let us look at the crack relief layer concept. A crack relief layer is provided over the CTB so that reflective cracking does not reach the bituminous layer. This is generally geotextile or stress-absorbing layer. And this concept has become very important in modern highways. Now let us look at the 10th topic. IMPORT engineering concepts. CTB reduces tensile strain. Improves load transfer. Increases strength development. Reflective cracks can propagate upwards if not controlled. And this is the practical concept of stabilized pavement behavior. Now let us look at the 11th topic. 1 practical site observation. Creates weak patches. Delayed compaction reduces strength. Improper moisture control affects density. Lack of curing creates surface cracking. And these observations are most visible during field inspection. Now let us look at the 12th topic. 1-2 quality control requirements. Now let us understand quality checks. Cement content checking. Moisture control. Density testing. UCS testing. Thickness checking. Curing inspection. And QC plays a very critical role in stabilized layers. अब इंटरव्यू क्वेश्चन बॉक्स देखते हैं. Q. What is the main advantage of CTB? Answer. High structural stiffness and improved pavement life. Q. Why is curing important in CTB? Answer. Because strength development depends on proper hydration. अब right side layer stiffness comparison देखिए. Without CTB pavement में subgrade stress ज़्यादा है. But by using CTB and CTSB the stress is reducing. And pavement strain is also reducing. This is the biggest structural advantage of the stabilized pavement system. Now see the thin versus thick pavement effect below. Thin pavement. More rutting. More cracking. Settlement. while adequate thickness, better performance, long life. Let's look at the one-shot revision at the bottom. CTB, Structural Strength Layer. CTSB, Stabilized Support Layer. Proper curing, better strength, poor mixing, weak pavement performance. CI family. Find these advanced pavement engineering concepts useful. So please like the video, subscribe to the channel, and press the bell icon. You keep getting such complete highway engineering lectures continuously. And in the next slide, we will understand reclaimed materials and RAP concept, where recycled pavement material, sustainable pavement design, and RAP utilization will be understood in detail. Teen, what is RAP? Now let us understand the RAP concept in detail. RAP means reclaimed asphalt pavement. It is milled or removed bituminous pavement material, which is reused in new asphalt mixes. Now look at its components. Aggregates, aged bitumen. This means that the old pavement material is not completely wasted. It can be recycled. Let us see its functions. Reduces material cost, conserves aggregates, improves sustainability. Now see the important points below. RAP is widely used in flexible pavement rehabilitation, and RAP is very commonly used in highway rehabilitation projects. Now let us look at the fourth topic. 4 advantages of reclaimed materials. Lower construction cost, reduced environmental impact, conservation of natural aggregates, reduced landfill disposal, sustainable highway development. And this has become the major direction of future pavement engineering. Now let us look at the RAP processing procedure on the right side. Step 8. Milling of old pavement. Step 2. Collection and crushing. Step 3. Screening and grading. Step 4. Mix design preparation. Step 5. Hot mix production. Step 6. Paving and compaction. और यही complete recycling cycle होता है. The arrows below are also showing the same flow. Old pavement removal, processing plant, recycled mix, and new pavement construction. Now let us look at the fifth topic. 5 challenges in recycled pavement. Now let us understand the common challenges of recycled pavement. Variability in material quality, aged bitumen stiffness, moisture susceptibility, मिक्सिंग कंट्रोल डिफिकल्टीज. अब नीचे इंजीनियरिंग नोट देखिए. क्वालिटी कंट्रोल इज क्रिटिकल इन रिसाइकल्ड पेवमेंट कंस्ट्रक्शन and QC is most important in RAP projects. Now let us look at the sixth topic. 6 important engineering concepts. Aged bitumen increases stiffness, improves pavement performance. RAP reduces the demand for virgin aggregates, require proper gradation control. And this is the actual engineering concept of recycled mix design. Now let's look at the pavement recycling and reuse cycle diagram in the middle. The old pavement was removed. Then processing and recycling took place. Then the RAP material was ready. And then new pavement construction was done. This is the circular pavement economy concept. Now let us look at the seventh topic. 7 typical RAP usage. Surface layer. Limited RAP percentage is used. Binder layer. Moderate RAP usage is possible. Base layer. Higher wrap usage is possible because the lower layers have higher structural tolerance. Now look at the right side pavement layer with wrap diagram. The BC layer is above. Then DBM binder cores, where wrap has been used. Then below are shown CTB, CTSB, and recycled materials. And the wheel load is being distributed downwards. This is a practical example of recycled pavement structure. Now let us look at the 8th topic. Art practical site observation. Improper wrap affects stockpile management quality. May increase brittleness. Moisture reduces recycled mix quality. Uniform crushing gradation improves consistency. And site management is very critical in recycled pavement projects. Now let us look at the 9th topic. No quality control requirements. अब QC requirements समझते हैं. Gradation testing. Bitumen extraction test. Moisture content checking. Marshall stability test. Density testing. Temperature control. And temperature control is very important in recycled mixes. Now let us look at the 10th topic. COMMON problems in recycled pavement. Segregation. Inadequate mixing. Low flexibility. Cracking tendency. Moisture damage. And improper wrap control can lead to the development of pavement distress quickly. Now let us look at the right side thin versus stabilized pavement concept. Poor recycled mix. Higher stress on subgrade. More rutting and cracking. Shorter pavement life. But in a properly stabilized wrap pavement. Lower stress. Better performance. Longer pavement life. और यही प्रॉपर रीसाइक्लिंग इंजीनियरिंग का एक्चुअल बेनिफिट है. अब इंटरव्यू क्वेश्चन बॉक्स देखते हैं. Q. What is wrap in pavement engineering? Answer. Reclaimed asphalt pavement reused in new pavement layers. Q. Why are reclaimed materials used? Answer. To reduce cost and improve sustainability. Now let's look at one short revision at the bottom. Wrap. Recycled asphalt material. Recycling. Cost saving plus sustainability. Good quality control. Strong recycled pavement. Proper mixing and gradation. Long-lasting pavement. And the most important thing. Sustainable today. Better tomorrow for our future. CI family. If you find these modern highway engineering concepts useful, so please like the video, subscribe to the channel, and press the bell icon. You keep getting such complete civil engineering lectures continuously. And in the next slide, we will understand overlay design and pavement rehabilitation, where we will understand strengthening overlay, pavement evaluation, and rehabilitation design concepts in detail. Okay friends, till now you have completed part 2. Let's do a quick recap. You understood traffic loading and axle load. Cleared MSA and VDF. Understood the CBR concept and designed CBR selection. And the importance of subgrade investigation and drainage also became clear. These are your design inputs. This is the foundation of pavement design. And remember, accurate input data means safe pavement design. Now the next step is clear. Now we will move towards part 3. Because now the actual pavement design logic will start. Part 3 we will talk about design principles, failure mechanisms and construction control. That means now you will understand why pavement fails, how to select thickness, and how to control quality on the site. And one important thing, if the design logic is not clear, then the pavement performance will never be stable. That's why part 3 is very important. So now let's go straight to the next video. Part 3 and move on to the actual design. If to you its series useful sound doing is. So civil engineering infrastructure subscribe take it. Video like came yes so like definitely do it. Own doubt or feedback in comment write. And this way only content for this our friends and colleagues with share also do it. On YouTube us follow @civilenginfra. On Instagram to connect @civilenginfra. Facebook and on LinkedIn to by searching Civil Engineering Infrastructure Connect. Here you will get highway engineering, pavement design, IRC concepts and site practical knowledge. Let's move on to part 3.